Hello, I am Dr. Amit Tak. Today we are going to discuss the physics of unipolar augmented leads. So as we know, there are three unipolar leads, VL, VR and VF. So before discussing augmented unipolar leads, first we will understand the circuit of the unipolar lead VL. So as you know, we can take here the left arm, here is the right arm, and here we can take the left foot. We will take three resistances from these points. Let's say this is resistance R1, this is resistance R2 and this is resistance R3. The point where all the three resistances join is known as central Wilson terminal. From central Wilson terminal, let's say its potential is W. Another wire goes and join here at the negative terminal of the voltmeter. Let's say the resistance of this wire is L4. Now one more wire from LA comes and joins at the positive terminal. So the voltmeter shows the reading VL. So as you know, the potential difference is LA minus W. So VL is potential at left arm minus potential of the Wilson terminal. Now we will see the circuit of VR. For VR, what we can do, we can remove this and we just join the right arm wire to the positive terminal of the voltmeter. So what we get is VR. So VR is RA minus W. Similarly, so this is the value of VR. Similarly, we can find the value of VF. For VF, what we will do, we will join a wire from LF to the positive terminal of the voltmeter. So VF is equals to LF minus W. So these are the potentials of the unipolar leads. But what is the value of W? We will find out the value of W in the next slide. So as you know, this was the setup, just taking the resistance R1, R2 and R3, and this is the Wilson terminal, let's say it's W, and this is the fourth resistance. Now as you know, the current in R1 is I1, current in R2 is I2, current in R3 is I3 and current in R4 is I4. On applying Kirchhoff's current law, that says that whenever there is a node, the incoming current is equals to the outgoing current. So here the incoming current is I1, I2 and I3 and outgoing current is I4. So we can write I1 plus I2 plus I3 should be equals to I4. So this is one thing. Now what is the current? As we know, we can apply here the Ohm's law. Ohm's law says current is potential difference upon resistance. So I1 should be potential difference over I1 is RA minus W and resistance is R1. Similarly, we can find I2. I2 is LA minus W over R2. And similarly, we can for I3 and I4. Here I4 is W minus 0 upon R4 and I3 we can write LF minus W upon R3. So we will derive the value of W. We can just write I1 plus I2 plus I3 should be equals to I4 and we just put the values of currents here. So I1 is RA minus W upon R1 plus I2 is LA minus W upon R2, I3 is LF minus W upon R3, and that is equals to I4, that is this. Here we take two important things. R1 is equals to R2 and it is equals to R3. Secondly, we are taking R1 very large. So what is going to happen? This equation becomes, we just write RA, LA and LF. RA, LA plus LF, and there are 3 minus W, we can write minus 3W divided by R, because these are equal, we will take it as R. And here R is very large, so we can take this term equals to 0. So this R also goes here. So what is left is RA plus LA plus LF. We can write it equals to 3W. We will take this 3 below this these terms. What we get is this. So this is the value of W. This is the value of W. So we can write the potential of unipolar leads. So as we know, in the previous slides, we know VL was LA minus W. So we can write here LA minus W. The value of W is 1 by 3 LA plus RA plus LF. This is the value of W. Similarly, we can write VR is equals to RA minus 1 by 3 LA plus RA plus LF. VF is equals to LF minus 1 by 3 LA plus RA plus LF. So these are the values of the unipolar leads. Still we have not talked about the augmented unipolar leads. So we have just find out the values of the unipolar leads. Now we will find out the values of augmented unipolar leads. Now we will see the circuit of the augmented unipolar leads. We will take the lead. So what is happening? One wire comes from RA whose resistance is R1. Another wire coming from LF whose resistance, let's say it is R3. Now one wire goes from here. Now one wire goes from here and joins at the negative terminal of the voltmeter. Let's say this is R4. This type of terminal is known as Goldberger terminal. Here wire from LA is not connected to this central terminal. So this is the difference between the Wilson terminal and the Goldberger terminal. Another wire from LA goes and joins at the positive terminal of the voltmeter. So the voltmeter shows the reading AVL. So as you know, voltage is the difference. So AVL is equals to LA minus G. Let we take it as GL. So AVL, augmented potential of the augmented unipolar lead, is equals to LA minus GL. Similarly, we can do for the VR. What can we do? For VR, we will take one resistance from LA, one resistance from LF, and we will take one resistance to the negative terminal of the voltmeter. Let's say it is R2, it is R3, and it is R4. And we connect one wire from RA to the right terminal of the voltmeter. So what we get is the AVR. So AVR is equals to RA minus, let's say it is GR. This is GR. Similarly, for AVF, we can write LF minus GF. Now, what is the value of GL? Again, using the same analogy as we did before, we will find out the value of GL. So, GL will be half RA plus LF. Similarly, GR is half LA plus LF, and GF is half RA plus LA. So we can write the potentials of augmented unipolar leads. AVL is equals to LA minus half RA plus LF. Similarly, AVR is RA minus half LA plus LF, and AVF is LF minus RA plus LA. So now we have the potentials of unipolar leads and augmented unipolar leads. Now it's time to compare these potentials. We just take the example of left arm unipolar lead AVL. So we are just comparing AVL divided by VL. So what was the potential of AVL? It was LA minus half RA plus LF, and the potential of VL was LA minus 1 by 3 RA plus LA plus LF. Now doing a bit of math here, we will take the LCM and we will write here 2LA minus RA minus LF, and we will put 2 here. Similarly, we will take the LCM here. What we get is 3LA minus RA minus LA minus LF, and we will put 3 here. Now, as you know, we can simplify it. 3 by 2, 2LA minus RA minus LF. Here 3LA minus 1LA is equals to 2LA and RA minus LF. So these both expressions cancel, and what is remaining is 3 by 2, that is 1.5. So AVL is 1.5 of VL. 1.5 means it's about 50% augmentation. So 50% augmentation. So before completing this lecture, why can't we check the Einthoven's law? So as Einthoven's law says, first lead is equal and third lead is equals to the second lead. Another law says AVL plus AVR plus AVF is equals to 0. So let's check this. So what we do, we will add these things. So here is the LA, here is the RA, and here is the LF. Here are the minus signs. So half RA is here and half RA is here. So I will write 1 RA here. Similarly, half LF is here and half LF is here. So I will write LF. And similarly, half LA is here and half LA I will take from here. So it is LA. So this expression comes out to be 0. So it means our Einthoven's law is fulfilling. Thank you. Thanks a lot.